So next up we have Solana, and as soon as Anatoly jumps into there he is. I'll bring him on, and we'll get an update on the latest on Solana.
What's their mission? And I kind of joke about this is to slay the vampire squid. Like if you think about what is the point of all this trustless, trust minimizing computing, I think it's to, fundamentally it's to eliminate mistrust, to eliminate fraud, right? And this kind of thing, I think it spreads itself just outside of finance, but to even things like getting constantly barraged by spam and advertisement and having your attention stolen unintentionally. To me, all this kind of falls into this one thing. And I think there's an opportunity for these trust minimizing systems to replace all of that with just software where we're not being constantly taxed by all these all these things that just seek something from us for free. It's think of it as our big mission, and we're a small part to play in it because all we're like a layer one. We're a blockchain, right? We're a layer one proof of stake. Fundamentally, no different than Cosmos in a lot of ways, but what we're focusing on is really latency and performance. So we raised some funds. We raised, I think, around 25 million USD from a bunch of investors like Multicoin, Slow Ventures, Foundation Capital, a ton of validators. That should say about 70 days of mainnet beta. We had one upgrade where we had to that didn't work smoothly, but we were able to coordinate without loss of anything interesting. So getting a lot of learnings from the Cosmos folks as well. When I wrote these slides, there were 80 validators. There's now 91 participating in consensus. It's already live. It's native. Some of the stuff we've achieved is we have 400 millisecond blocks. So what that should tell you, in about 70 days, we are actually at around 14 million blocks. So we've passed Ethereum, I think about 10 days ago in block count. It's all about blocks, right? Our kind of shtick to scalability is not sharding in any way, but really relying on Moore's law. So we've parallelized and pipelined everything we could. So theoretically, every time you double the cores, we basically double the capacity. And the way we've designed our smart contracts language is you can even execute it on GPUs because it uses a stack-free virtual machine. So there's an opportunity for us to really scale up to whatever hardware NVIDIA and Intel ship. And to me, that's a really kind of a strong differentiator from what other folks are doing. Is that I don't want to ever be in a situation where we have CryptoKitties taking up all the capacity of the network and there's nothing we can do. I will literally fly around the world and give the super majority of the network, all the GPUs and CPUs that they need to make it work. So where's our ecosystem right now? We've been mostly focused on, because of our latency and capacity, we kind of taking a slightly different approach from a lot of other folks. We are targeting projects that have a need for this. I think the hardest part in the space is finding product market fit. Who needs a blockchain, right? that is, I think, the ultimate question. So our approach has been finding folks that have found some traction and really selling them, here's a faster, cheaper version of this that is as decentralized as Cosmos. If you look at our set of validators, the intersection between us and Cosmos and probably Tezos is the super majority in all the networks. And that is, honestly, a testament to the awesome work that the Cosmos folks did in actually building this professional validator community. But we are, I think, fairly decentralized and fairly fast. So why us? Or I guess this is our team. If you guys don't know who we are, it's a bunch of ex-Qualcomm folks with some friends from CERN and Silicon Valley. But what does Qualcomm have anything to do with blockchain? Well, it's they basically built all the technology that goes into LTE and WCDMA and CDMA. And those are the largest distributed systems in the world, largest networks in the world. They're like the biggest things that, in some ways, the biggest networks that humanity has built. Over 4 billion devices out there, all interconnected and can talk to each other. And fundamentally, how they coordinate all this stuff is using time. And time is really a fundamental part of distributed systems. And it is also part of, proof of work. The whole idea of Bitcoin and its difficulty adjustment is to produce blocks every 10 minutes. And this is to basically satisfy a lot of the data propagation and data delay requirements that proof of work relies on to maintain consensus. So it really needs those blocks to propagate to everybody in the network to kind of maintain this one consistent state. There's other ways to solve this problem, right? LTE, CDMA, TDMA, like those old school 2G networks. In fact, the first radio networks that were built, they have the exact same problem, right? Two radio towers, when they talk at the same time over the same frequency, you get noise in the air. So the first thing that people did is give every radio tower a synchronized clock. So they would alternate by second or however well you can synchronize those clocks. And when you don't collide at the same time, you don't get noise, and therefore information can propagate. So this is our basic idea, except instead of a trusted clock, we use a very, very, very dumb, very simple verifiable delay function. I actually talked to Dan Bonnet, and he said, you can call us a verifiable delay function. So I'm going to call it a verifiable delay function. But it's really sequential hash function, SHA-256, that loops over itself, and we sample it. So there's no fancy math. It's as simple as an operating systems engineer can build it. But it's very, very kind of easy to work with because SHA-256 is pre-image resistant. It's already has optimized hardware and Intel and AMD. It's going to take you tens, if not hundreds of millions of dollars to significantly beat those implementations. And we can verify it on very common hardware. Your phone has about 1,000 symbiolanes, so you can verify a second to in a millisecond, right? In a microsecond. On a GPU, it's a quarter microseconds. So that's not really a clock, right? It's just a data structure. But just like the New York Times, right? And then this picture of Obama in the New York Times, and then Obama looking at the New York Times, you can deduce that Obama was alive at some point between those two photos, right? Those were the good old days. So based on the same concept of looking at kind of points in this data structure, we can also generate a source of time and difference between events. And that's kind of like the secret sauce. There's a big pile of other stuff, but most of it is really just kind of blood, sweat, and tears engineering of looking at a bunch of traces and samples and memory and trying to optimize and remove bottlenecks and like get things distributed into a large set of cores. If you combine all our networks, there's, I think, about 150 validators live. Some are in Mainnet, some are in Tour de Sol. Our target for transaction fees is $10 by Z-million transactions and sub-second block times. And we can, with a bunch of tricks, give you sub-second optimistic finality optimistically sometimes. You can think of it as like 84% of the time it works 100% of the time. So like some of the stuff we're working on is, obviously who needs a fast blockchain? I think during Black Thursday, we kind of discovered that when you do have limited block space and high fees, and those fees can shoot up due to like these peak demands, markets may fail, right? So what we want to do with Chainlink is build a high frequency oracle that feeds a price every 400 milliseconds. And based on that kind of price feed, I think you can build much better, faster kind of products for settlements and stable coins and binary options, and you can kind of imagine a much more like much less risky ecosystem for DeFi if you have more speed and more capacity. But obviously, high speed payments We had an announcement with Terra. If you kind of Google it, gives you an overview of what we're working on. There's an obvious intersection there because you can think of point of sale payments, kind of the Visa standard is 2.5 seconds. With optimistic finality, I think we can get there most of the time, and that's kind of a key key metric that folks that want to break out into like end user point of sale stuff really need to hit. And Kin is a project that is like, to me, like really interesting because this is one of those use cases that really depends on ridiculously cheap transactions, right? If you look at the web, it's like point of value is ad view, which is 0.2 cents, right? And it's delivered under 200 milliseconds. If you really want to have a shot at like creating an ad-free web, you need to be 100 times cheaper than that. We're 200 times cheaper than that. So literally you can do an event, right, between a user and this whatever social network or ecosystem that they're participating in the web, and that event would cost less than an ad view. So much less so that the network itself can now generate a profit, right, from this network activity. And that is like, I think, a viable path of actually getting rid of advertisement from the web altogether, and that's one of the vampire squids that we want to destroy. There's a bunch of resources. Solana.com will kind of get you everywhere. All our engineers hang out on Discord. We have a podcast if you really want to hear like the latest episode we published with Tarun. Awesome person. We talked about everything from the Black Thursday crash to anti-fragile systems and like the craziness in the space. A bunch of weirdos in Telegram. But if you really want to code, check out our GitHub. We have a tons and tons of code and documentation. So let's see if I can actually, if the demo gods are with me. Do you guys hear me okay? If you guys know Wolfgang, he built this dashboard for us. This is our mainnet. So 14 million blocks. Woo! Got to make those blocks. 460 millisecond block time. So non-optimistic finality is like where the chain cannot roll back no matter what happens. Is this far? So it varies. We kind of effectively can think of our consensus mechanism as almost like a sliding window for PBFT. It's what like the two optimizations that engineers know how to do is give it a sliding window so you can do more things at one time, right? And parallelize the hell out of everything. That's basically all we did. And our validators go up to 91. So this is mainnet beta. Why is it beta? It's because it's new code. Literally, this was a bunch of engineers, even though we all worked together at Qualcomm for like 10 years, wrote this thing on a lot of caffeine, almost 200,000 lines of Rust. None of us were Rust developers before this. We're all C++ developers. So it's beta for a year. Literally, like I think we launched, it's feature complete. Our nodes have a super minority of the network. It's not quite as cool as Cosmos, where they didn't have anything. This is just basically our way to bootstrap it, but it is like a totally decentralized open network with real finality guarantees. So for us, that's I think a pretty cool achievement, as close to mainnet as we can do it without taking on more risk. So it's, from my perspective, like the beta tag stays on there for a year, and if we don't have any catastrophic failures, then we celebrate. And so far so good. And like Tour de Sol is our testnet, and it's got people attacking it, and like when we release new features, sometimes those features have bugs, and those bugs have been exploited to like an actual theft of funds. So like if you guys Google Chorus 1, executed one of those, but so has Certus 1. So we have like an actual awesome like hackable network with people actually hacking each other. And this is like something that I couldn't have imagined of, like that we were going to actually accomplish and execute. So I'm super proud of it. And it's got way more validators on it, and this hardware is not as optimized, and block times are worse, and people try to like DOS each other and do weird things. But it's pretty cool because it's still running, and it kind of allows us to stress test some of these like synchronicity assumptions that we have about the sliding window and things like that. And if I'm lucky, the demagogues are going to be with me. So, okay, so this is on that testnet that's kind of flaky. And this is me just mashing keyboards, trying to get as many transactions as I can. So, right, this network is flakier, has more down nodes, more downtime, and you kind of see this behavior, but still pretty cool, right? And staging, unfortunately, is not okay. Well, I could have showed you the optimistic case where it confirms in 400 milliseconds, but unfortunately, the cool thing doesn't always work. But some of the cool things you can see is that like these transactions are validator votes. So kind of how we design the network is that everything is going through the same engine. It's kind of like the common path is the complex path approach, and that basically is a forcing function to make sure that pipelining, parallelization, all that stuff doesn't cause failures, unforeseen failures. And that's been kind of an important part of our development, actually bulletproofing this really, really complicated system. I don't know if we would have been able to ship all this stuff if it just wasn't like forced to work. So yeah, that's about it. Please ask questions.
Yes, yeah. If anyone has questions, drop them in the chat. I had a couple that I definitely want to run by you. So I know like the crown jewel of scaling that we've been talking about over the past few years has been shard chains or sharding. And I think it's one thing that Solana's kind of been from the start kind of anti-sharding, and that hasn't been one of the top things that you've been exploring. And I was just kind of wondering what the ideology, the rationale behind that.
Honestly, I thought everyone else was going to do the same thing because I thought it was so obvious. Like, how else do you scale if not use like hardware that gets better every 2 years? Like literally when we started, we needed 4 GPUs to get to like 1 million signatures per second. Now you only need 1 because they both optimize the math behind it, and the like just the number of cores per GPU card doubled, right? So you kind of get into these like, it's an exponential function. You don't want to be on the other side of it. Like you literally, right? Like hardware is like one of those industries that like a lot of stuff stands on. So from my perspective, this seemed to be like the obvious choice, because even if you're worried about decentralization, all you care about is maximizing the number of participants in the network. The cost that effectively drops by half every 2 years. And to give you kind of an example of what that means, if you look at like Ethereum, one, the staking requirements are pretty high, right? You need 32 ETH, that's roughly $6,000. We don't have any minimum staking requirements because the network can just take the spam. So for that same amount of like, people say, oh, you can run Ethereum on a $500 laptop. Well, for $500, you can actually buy 500 seconds worth of compute and generate 500 slots and be a block producer and actually get staked and produce those blocks in Solana. For $500 on Ethereum, you're not going to do shit. so that's like honestly is like a, I don't know, like to me like everybody in the space, I think we're all in the same boat. All of us want to build like these fraud-proof systems and really get rid of the world of like this kind of like regulated financial systems that are rife with like rent seekers and like fraud and scammers. Right? We're all doing the same thing. We're all fighting for the same cause. So like,
yeah,
I think I think it's important that we have multiple options and multiple teams like really working hard and making those succeed. At the end of the day, right, if any one of us wins, we all win. So,
Well, I appreciate the insight. Thanks for joining us. We're running out of time. Where can we keep in touch with you? Someone asked what's your Twitter and how we can stay up to date with the project.
So Solana.com, obviously, and at Solana Twitter. So we have like all the good names, all the good domains. Yeah, and you can ping me in Discord, Telegram, fairly easy to find, email.
Excellent. Thank you. Really appreciate it. Hope we talk soon. And yeah, see you soon. Best of luck with the next steps.
All right. Thanks. Take care.
Yep. You too.